Hello everyone, it's Zenith20 back again, and in this video we'll be creating a cool looking memory game using HTML, CSS and JavaScript. So let's get into it. So first of all, to create a memory game, we're going to set up the basic HTML structure, which will be really easy. We're first of all going to have a div with a class of board, and we're going to put this inside a container. Or maybe we can do the container later. Let's just focus on the board. All right, so with the board in place, we'll first of all style the body tag with the basic styles. We'll give it a background of gray, make it a flex, and align all of the items to the center and justify them as well. All right. Next, we will take our board and we are going to define two custom properties: width of 70 view minimum and a height also of 70 view minimum. See, what we are basically trying to do here is that we're trying to make a very customizable memory game. That's why we're going to store all of these potential variables as CSS custom properties. We're going to modify the width and height according to the size of the board and the number of cards on the board. So suppose if we wanted to play with 30 cards, so we would have to change the board variables again and again. So we will keep them inside CSS custom properties to make it easier for us to access them. All right, with that in place, let's set it to the width and let's also set the height. We're going to give it a background of gray and a slight box shadow of 0 pixels, 0 pixels, a spread of 15 pixels, black. And we're going to give it a border radius of 20 pixels. All right, let's give the body a height of 100 view height and prevent its overflow. All right, we have our board in the center. Now let's move on to the cards. So before I try making the cards by JavaScript dynamically, let's think first of all, how exactly would a basic card for memory game look like? So we'll first of all have another div inside the board, and this div will be given a class of card. In this, we're going to have further two divs. Both of them will be having a class of side. The first one will be the front side, and the second one will be the back side. Now, the front side should not have anything, but the back side should have some sort of emoji or whatever text we're trying to show. In this case, we'll be using emojis. So we can suppose take an emoji of a smiley face. And there we have our card with no styles right now. So back in the index CSS, we're going to take our card and we'll apply basic styles to it. First of all, I'm going to give it a background of blue so we can see where exactly is our card going. All right. Then let's give it the width of, actually, let's define in the board rows and columns. So there will be, for example, by default, let's just think of 4 rows. And we'll think of 5 columns. Remember that we will be using these in JavaScript. Okay, why did I assign rows and columns over here in the first place? Well, we'll be assigning the grid to the board. That's why we're going to use the rows and columns. And we'll also be using the rows and columns in calculating the size of each and every card to dynamically size them according to the size of the board. So first of all, we'll take the grid template column. First of all, in fact, let's display our board as a grid. Then grid template columns will be set to repeat var rows, and we'll give one fraction to each of the row. We'll do the same thing with the columns. In fact, yes, this will be columns over here. The first one will be columns and the second one will be rows. All right, that's our grid in place. Next, what we're going to do is that we're going to calculate the width of each of our cards. So suppose I'm going to place 2 cards for now. All right. So we're going to determine the width of each card. So we'll introduce calc and we're going to take the number, we're going to take the width of our board and we'll divide it with the number of our cards. So the number of cards on one single row should be width slash divided by rows. So what basically this does is that we'll be setting the width of it according to the number of rows on our grid. So in this case, we'll be using the width by you calculating the rows and the width of the actual board. So you can see we have exactly 5 cards over here. Next, we're going to give a slight border radius to all of these of 10 pixels. And we're going to subtract a little bit from these so that we can have some gap in between these cards. So let's take a gap of 2 view minimum. Now, why did I use 2 view minimum and not 2 pixels? That's because in calc you should use the same units for the units. So if you're going to use 70 view minimum or if you're going to use 70 pixels, then same in the calc you'll have to use this 2 pixels or 2 view minimum in the same order. Otherwise, there will be a conflict and you won't be able to use the calc, or the calc won't be able to give correct results. All right, that's the width done. Now let's move to the height of the card. And in this, we're going to set it to height of the board divided by the number of columns. And that's it. We got a nice looking card over here. All right, let's give some padding to our board. All right. Now we'll display flex on our card so that we can align our emojis to the center. Okay. Next, we are going to increase its font size because currently its font size is too small. 20 pixels seems all right. We may go for 30. Okay, 30 is fine. Or maybe 25 or 30. Okay. So we'll go with 30 font size. But currently, if you try seeing this, this is not the card, but this is the front face. This is the back face of the card. We need to implement the rotational animation on the memory games, which you have often seen while playing many memory games that the card rotates when you click on them. How can we implement this? That can be easily implemented by giving our side the background. First of all, the card should not have the background. The side should have the background. All right. And we are going to give it the width as well and the height as well. All right. We're going to pull the display flex and all of those properties and we're going to place it in the side. All right. Maybe we should also put it in the card. Yes. Okay. Next, we should the font size. Yes. Next, we should set the font size, which I already said. So we'll take then the border radius. All right. We have 1, 2, 3, 4. Okay, 4 of the cards. All right. So this should be set to position absolute so that they'll be aligned within the card, not position relative. Position absolute. Make sure that you make the card as position relative so that the side position relatively to the card. All right. Maybe if we remove the flex properties. Yes, so now we can remove the flex properties from the card. So the card does not require the flex property. The side requires the flex properties for sure. That's the sides done. Now we're going to put one important property to the side, which is back face visibility. You see, when we try to rotate any of the HTML elements, it will show its contents when it's rotated as reversed. I'll show what does this mean. So if we rotate, if we transform, and then we rotate our card on the y-axis to complete 180 degrees, you can see that our cards are basically now reversed. We do not want to show the backside of our cards because it is still showing the content. So what's the purpose of flipping the card? So if we set the backface visibility now, backface visibility as hidden, you can see that the backsides of the cards are hidden. Both of them are hidden, which should not be so. Therefore, we are going to not have the transform property on the side because that's the journal class. So in the backface visibility, we're going to set it to hidden. And then we're going to go to the individual sides. So the front side will have a transform of rotate y 0 degrees, whereas the back side will have a transform rotate of 180 degrees. That's it. So we can now see that our back side is rotated. So we can't see the back part of this, and the front side is now facing towards us. Now we'll just pull these dot front and dot back. Or in fact, let's just place it here. But we're now going to add 2 additional rule sets, and that will be card dot flipped. This will basically be a CSS class which will be triggered by the index.js. It will be triggered by JavaScript and it will be placed on the card which are being flipped. So each of the cards, if suppose it's having the flip property, if our first card is having the flip property, our card should be flipped and we should be able to see the backside. So it's as easy as just reversing these 2 properties. So if card.flip, we can take these, we can place them in here using CSS nesting. Give these some nice indentation. And we'll completely rotate them opposite. So we'll make the front side go backwards and we'll take the back side and we'll make it rotate forwards. And that's it. So we will basically define that when the card is flipped, we want the front side to flip backwards and we want the back side to flip towards the forwards. And now you can see as it's been flipped to forwards, the back part or the front part of the back side can be seen. Now this may not look so clear because it's not, the animation is not at all applied to it. So we can add the transition property to the side of 0.5 seconds. And now you can see it's rotating. Make sure you set transform style to preserve 3D. Otherwise, we'll have janky 3D animations. So if the card is flipped, we'll have the front transform rotate. Okay. We'll also take these dot front and dot back and we'll place them in the card like so. Or maybe we can just keep them separate here. Maybe you can also separate these for the sake of clarity. So it was dot card dot flipped. So we're looking for the front side when the card is flipped. Same case we'll do with the back. All right, let's try switching the flipped. Okay, the animation is still very subtle. Well, we'll be able to see that when we'll start in the index.js. So currently we have 2 cards over here. We can see that upon flipping them, we can see the backside, and upon changing the flipped class, we cannot see the backside. Okay, let's just keep this flipped. Now in the index.js, we're going to have a bunch of functions. We're going to first of all set the cards. So we're going to create our cards dynamically using JavaScript because we want to dynamically set the number of cards we can play. Suppose if you want to play with 4 cards, you can set the values in the JavaScript to 4. If you want to play with 8 cards, you can set the value of the rows and columns to 8 in JavaScript, and it will dynamically create the cards. So that's what SetCards will do. FlipCard will handle the flipping. UnflipCards will basically handle unflipping of the card and highlighting those cards which are correctly paired together. CompareCards will compare for us whether the two cards which we have chosen have the same emoji on them. And the restart function will be helpful when we'll create the restart button. And the CheckWin is essential for telling the user when he has won the game. And lastly, update labels, because we'll have to add some extra labels of showing the number of moves. So before we add any of these functions, we are going to bring our board. So document.querySelector dot board. We're going to define the number of rows. Let rows equals to 4 and let columns equals to 4. Next, we are going to set board dot style dot set custom property. We're going to take the rows custom property which we had set, and we'll set the value to the rows. We'll copy this and we'll place it for the columns as well. All right, if we try switching the rows and columns, we can see that currently there is no style being applied. Was it on the board? Rows, columns, all right. Okay. So we have the board.style set custom property of the rows and columns. If we try looking into the inspect, we can see that our board should now have the properties. Okay, maybe I didn't refer it somewhere. Document.querySelector board.style dot set custom property. What if we remove these? Okay, we're just having one grid. Let's just set this back. Having 4 grids, let's try changing it to 8. All right, so I can see where is the problem over here. So we can see if we go to the console that we have the problem on type error board.style.set custom property is not a function. Basically, we had defined the method wrong, so it is set property. And we can see we're getting the correct grid now. If we'll go on to the elements, select on grid, we can see it's changing it to 8. And if we change the rows and columns, it's setting it to 4 grids. All right. Next, we are going to start writing the set cards. But the last thing which we'll set before that is an items array. That items equals to an array. And basically, in simple terms, this will contain all of the emojis which will be used by the grid. And it will contain the occurrences of the number of times that the emoji is being used. In a typical memory game, each emoji or each character which you're using as to place on the card comes up in pairs. So if you're having one smiley face over here, there must be another smiley face somewhere within the grid. So each of those emojis should come in pairs. Otherwise, the game is basically unsolvable because there are no pairs to match. So therefore, in the items, we're going to have an array of objects where we'll have the icon as any emoji. Let us set it to smiley face. And we'll set the occurrences to 0. All of them will have occurrences of 0 in the beginning. We'll copy this a bunch of times. All right. Next, we are going to change these emojis. Otherwise, there will be no variety in the game. And there we go. Make sure each of these icons are different. Otherwise, there will be a mismatch. So we have our items already ready. And another tip before you go on to making these is that make sure that if you're trying to expand your game to have more and more cards, you should be also expanding your items. Although the way I'm going to create the memory game, it will be able to mitigate that error by reusing those icons. So suppose if we have completed a pair of the smiley faces, we will then reset the occurrences to 0, and then we can use it for creating another pair of it in the game. But then again, it will reduce the complexity of the memory game and it will reduce the fun in the game. So make sure you extend the items array if you're adding more rows and columns. Second important thing is that the rows and columns must be an even number. And I'll show you further into the tutorial how is that important. So first of all, let's declare our setCards function. We're going to call that setCards in the beginning. And in the setCards, we'll have a for loop for let I equals to 0. I is lesser than rows multiplied by columns. I plus plus. And we're going to create a card document dot create element. It's a div, and we're going to add the class list class card dot class list dot add card, and we're going to add to the inner HTML card dot inner HTML equals to the HTML which we wrote over here. So we can copy this and we can place it here. Okay, so the front side won't have anything, but the back side will have a value, and that will basically be the icon. So how exactly are we going to make use of an icon only 2 times throughout the whole game and always create a pair of it? This might sound complex, but the easy way of it is to break down this items array into those objects or those items or those icons which have been unused and those icons which have only been used once. There's another danger because if any of the icons is only used one time, that icon will basically not have any pair, and then it would make the game completely unsolvable. However, it's much safer that if an icon has 0 occurrences, it's not in the game and it won't be used by the user. Therefore, it's much important to solve the occurrences to do if the occurrences are equals to 1. So, for example, if we just take the icon, or if you just take the item, let item equals to math dot random. Make sure we use random because we always want the game to be randomly generated. Multiply with rows into columns. Place this in brackets. Or in fact, let's just make this to items dot length. Yes, it should be items dot length. That will give us the random. We're going to float this math dot floor. This will give us this whole expression over here will give us a random index. So we'll copy it and we're going to take items and we're going to select a random item from it using this expression. Then we can take that item over here and we can show its icon. And there we go. We still have to append that item. Yes. All right. So we have created the card, but it's not showing up on our screen. Why? Because we haven't yet appended it to our board. So we append the card to our board and now we can see that it is overflowing. Why? Because of these 2 cards over here. So we'll just delete these two cards. And there we go. We perfectly have our cards over here. Let us just set for now the value of flipped on these. We want to see what these cards are holding. All right, so each of them are holding random. But if you try to now think of making the pairs, the smiley face has only the smiley face at its pair. The O face also has its pair. But if you try to look at the laughing face with the tears, it does not has any pair. So how is the player supposed to solve this pair? How are they supposed to find the pair for this specific card? Therefore, to mitigate this error, we are going to split. First of all, in the beginning of the for loop, we're going to create let unused items is equals to items dot filter, and we are going to return the item which has an occurrence of only one. Those are the no, those will be not the unused item. Those won't be the unused items. These will be the single, yes, single pair, single items which just have been put into the grid once, but they don't have another single one to make a pair. And then we'll create another filtered array, and these will be the unused items, which will only contain those items which have not been used at all in the entire grid. These are the two arrays which we have made over here. So what we're going to do now is that we are going to, first of all, check if single items is greater than 1, not greater than 1, greater than 0. So we're basically checking if there is any single item inside this array, or if there is any single item inside the items array, because we do not want to have a single of those emojis onto the grid. We want to have a pair of all of them. So we're first of all going to resolve those items which are in single. So we're going to have if any single items, so then we're going to take an item from there. So we're going to pull our item. So let items equals to single items. Going to take an item from our single items array. So we're saying, yes, if there is any single items, make sure this single items dot length. If there is any single item, we're going to take a random single item from the single items array, and we are going to set the item, and we're going to also set the items occurrences to +1. Make sure that you're changing the occurrences to +1, because we are of course putting it now into the grid. The next thing we're going to do is that, in fact, let's just define this item outside of the if condition. Otherwise, it's being scoped inside the if condition. So we're going to pull our let item above. Okay. Currently, there are no single items because there are no items in the first place. So if there are no single items, then we're going to check in unused items. So again, we'll take the selection of the item statement over here, but instead of searching inside the single items, we'll be searching inside the unused items, which will basically be the entire array in the beginning. All right. So we have now successfully made one pair, 1, 2, but we still don't have the pair for the other faces. All right. Unused items. Okay, we have to make another check over here. If our, or we don't need to make this check, item equals to unused items, math.random. Okay. Okay. So what's the problem here? We just need to add the item.occurrences plus equals to 1 here as well. And that resolves it. And that has given us a grid in which we're getting pairs of each of the emojis. Now, do you notice any weird pattern over here? The weird pattern over here is that we're getting adjacent same icons over here. What's the purpose of the memory game? The player would easily find this pattern, then they would click this, and then they would click the next card and the next card and the next card. We don't want that to happen. We want them to be randomized. But before I go any further, I want to add the flipping of the card. So we can go in the end, after we append the card, and we can add an event listener, card.add event listener, click. And if they're clicked, we are going to trigger the flip card function, which we can define below. Function flip card. We're going to take in it the event. And basically this will do event dot target dot parent node dot class list dot toggle. Why toggle? Because toggle will switch on and off the flipped. So if there is a flipped class inside that HTML element, it's going to remove it. And if there's not any flipped class inside the parent node, it's going to add it. So it's basically 2-in-1. It adds and it removes as well. So we'll just toggle the flipped class. All right. The flipped is working perfectly fine. So yes, we are able to flip our cards. For aesthetic purposes, let's just change our cursor to pointer. I think that would look pretty good. So on the card, let's change the cursor to pointer. All right. That's all of our cards here. Next, we should see how we can remove these adjacent pair pattern. And to remove this adjacent pair pattern, we can do a clever trick over here. When we are using CSS grid, we are given access to a property called the order. The order property basically changes the order of the HTML elements. So if this first element is having an order of suppose 10, it's going to appear somewhere over here. And the element which was over here is going to take its place over there. It's going to swap the places. So we can easily do that by taking the card dot style dot order. And this will be math.floor math.random. Let's just write it math.floor math.random. Make sure math is in capital. Math.random multiply with rows, multiply with columns. And that should randomize our cards. And we can see this in action if we go back into inspect and we check inside the body, inside the board, we have our cards over here. And you can see all of these cards are having a random order. So the first one is having an order of 3, so it's in the 3rd position. And the second one is having an order of 0, so it's the 0th position. There we go. We have now made them randomly placed. Now we can remove the flipped class list. But before I remove the flipped class list, I had mentioned somewhere earlier that why we should not set the rows and columns to an odd number. Well, watch what happens. If I'll set the rows and columns to an odd number, we get a pair which cannot be resolved over here. But if we set it back to an even number, our rows and columns fit perfectly. But there's another issue with this. Currently, our game may also run out of possible cards which it can try to make. If we set this to somewhere around 6, you can see that our SetCards function has just suddenly stopped over here. Why is it stopped? Because I had mentioned that our items can only make certain combinations, and after that, it can't make any more combinations. All of the occurrences have been made to +2. And as they are made to +2, no more cards are being accepted. So we can add an easy check somewhere above here before the let card. We're going to loop through items and we're going to loop over them. We're going to say items dot for each item. We are going to check if item dot occurrences is greater than or equals to 2, then we set the item dot occurrences equals to 0. And this allows us to use more than one pair of the same item. So if we try to find, we have one pair of the smiley face And we have also many pairs of this face. And then we have more pairs of the smiley faces. So basically what is it doing is that it's reusing each pairs. You can try counting it and you can see that there are exactly 4 pairs or 2 pairs wherever you'll find the single icon. That's one thing resolved. We can now see what will happen if we set the rows and columns to somewhere like 3. So you can try now finding the pairs. The pair of this and this is there. The pair of this and this emoji is there. The pair of this and this emoji is there. The pair of this and this emoji is there. But there is no pair for this emoji over here. So again, the game is unsolvable. So let's keep it to 4. All right. Now that we know that these all have the correct emojis, let's just remove the flipped class list from the card. And now let's go on to making the UnflipCards function. And let's declare above, let current card equals to undefined. This will basically hold the current card and the target card for us so that we can use it for comparison and flipping them back over. So we'll have the current card and the target card. And in the flip card, we are going to check if current card is, or we can just check if not current card, then current card is equals to event.target.parent node. And we'll copy this and flip that card. Else if not target card, we're going to set the target card to flipped. Real easy. You can see we have 2 of them flipped and then we can't flip anymore further. That is done. But we've also seen that the cards must flip back over so that we can select another pair. That can be easily done by checking that if there is no target card, we set the target card, and then after that, we have now been confirmed that we have the current card and we have the target card. So once we have both of the cards, we can set a short timeout and we can make it somewhere around like 500 milliseconds for now. And what we're going to do here is that we're going to set the current card to undefined. Or in fact, no, what we're going to do is that we are going to flip back over both of the cards. So we're going to remove this parent node, all of this. We're going to set target card to flipped back over. And then we'll copy this. And then we're going to set the current card to be flipped back over. So now if we try flipping our cards, it is flipped back over. But we can't still further flip over. And I'll tell you where exactly we will allow that to happen. So before the set timeout, we will call one very crucial function. That is the UnflipCard. Or in fact, it was UnflipCard which we have to call. Bring the UnflipCards in the set timeout. And in the UnflipCards, we are going to unflip our target card and our current card, as well as we're going to set our current card to undefined. That's going to allow us to select another current card. And we're also going to select the target card to undefined. This basically resets all of the system which was selected by the player. So if we now try flipping the cards, it resets. We can now flip another pair and it resets. Perfect. Now we want to compare cards. Right now it's flipping, but there is absolutely no comparison which is going on between the cards. In CompareCards, we're basically going to check and we can return it, or maybe we can check. Yes, we can return it. We can check if current card dot children dot 1. Why children 1? Because we're basically accessing the parent card over here. So if we uncomment this, we basically are holding the parent node over here. We want to take the parent node, which is the current card, and we want to get its second children or the second child basically, which will be as 1 if we're starting from a 0 based array. Not the front one, we want the back one. And when we'll have access to this child, we're going to check its text content and then we're going to compare it with the second card. Let's comment this back. And we're going to check if current card children dot 1 dot text content is equals to the target card. The target card's first child. This will basically return us a boolean, which we can check against in the UnflipCards if compare cards. So if compare cards is equals to true, we are not going to flip the cards. We're just going to keep it as it is. But if it's not the same, then we're going to flip the cards. All right. That should be it. If we try flipping this, they are not being unflipped. If compare cards, if current card dot children, okay, should be children. The slight type over here. Okay, if you check these, it's the same. These are not the same, so they flip back. All right, that's working fine. If you're getting the wrong pair, it is flipping them back over. If you get the correct pair, it keeps them. But there is another issue over here. We have the smiley face here, and we also have another smiley face here. What if I click this? You can see it has just flipped these. And basically, we're still able to unflip these cards, which should not be allowed. So we can do one easy thing, and that is if we have the correct cards, we're going to take our target card and we're going to, instead of adding the event listener, we will remove the click event listener. Because in the end, once we have selected the correct pair and we have found that these are the correct pair of cards, we do not have to do anything with that. And even the user does not have to re-click the cards. So we can just remove the click event listener of FlipCard. That's from the target card. And this one will be from the current card. Now, if we try again, not the same, not the same. These two are same. And now if we try reflipping them, we cannot reflip them. And that's it. And you can also see that as long as we're not choosing a pair, this card is not flipping back over. So once we choose a pair, then only it flips back over. That's one thing, but currently there is no indication whether if this is the correct pair or not. I mean, the user can understand that these are the correct pairs, but we can give another indication, a good looking indication, if our cards are having the same pair. So we can add additional styling of dot side or wait, dot card dot correct. This will have a background of radial gradient. We'll start the radial gradient at the center and we're going to choose a blue color. Any blue color should be good. We're going to take this and we're going to add a green color outside to indicate that this is the correct pair. If we refresh this, card.correct should have a background of this. And we can also add a box shadow of 0 pixels, 0 pixels, 10 pixels, and give the same outline. And we can give a slight border of 1 pixels solid so that it will look like that it's being a neon card. So that's a little nice effect. Currently, we're not using this. So to utilize it, just before we remove the event listener, we can take the target card and current card and we can add to it. Make sure it's add, not toggle. We don't want to switch off the cards. So we can add to it the correct class. Simple as that. So now let's find the correct pair. There we go. We got the correct pair over here. the styling is a bit off. So instead of adding it on that, if card.correct, we should add it on the side. Yes. Yes, now it looks good. It should be on the side, not on the card. The dot correct is applied on the card, but the styling actual is applied on the side. Now the normal cards look a bit bland. So we can change those and add a gradient to them as well. So instead of having just a blue color, we can have a blue color, and along that, we can have a purple color. Somewhere around here. Should be good to go. And we can give a box shadow along with the border of the same color as well to add that neon effect. Take that and add it to the box shadow and the border. That should be done. Okay. Currently, there's too much muddiness in this. So let's try reducing the size of the cards. Okay, that should clear up stuff a bit. Next, there is some offset within each of these cards. If we try looking closely, there is some extra offset at the borders. All right. We are having that extra offset because we have not aligned our cards. So we go to the board rule set here, and we're going to align the items center, and we're going to justify items center. That should align everything to the center. Nice. Now that's most of it done, but we also want to check for winning. So we're going to have a function that will have CheckWin, and it's basically going to loop over all of the items. Not all of the items, it's going to, first of all, let's get all of the cards. Let cards equals to document dot get elements by class name of card. Now we want an array from our collection of cards, and we're going to loop over them. For each card, if the card dot class list dot contains flipped, if not the card dot class list dot contains flipped, then we turn the result variable, which I'm just going to define in a minute, to false. We'll define the result variable outside. Let result equals to true. So basically we are checking now that we're taking each of the cards, and we're checking if all of the cards are flipped. If any of the cards is not flipped, or they don't have the class of flipped, that means this card's pair has still not been found, and therefore return the result of false. In the end, we're going to return the result. That's it. Now, after every comparison of the cards in the unflipped cards, we're going to check if CheckWin, then we alert the player. You have won. And now let's try solving this. And there we go. It gives us the alert, you have won. And that's it. We have resolved all of this. But what if the player wants to play the game again? It would be a nuisance if they would click the refresh button again and again. So therefore, we're going to add the restart function. Very easy. We just have to write the function of restart, which will just restart some of the properties. First of all, we are going to set all of the cards to be unflipped. So we're going to loop over all of the cards. Or in fact, let us just take the board. Let's just take the entire board, take the inner HTML and wipe it out. That should be much greater and much efficient. So we have the inner HTML wiped out, and then after that, we're going to set moves done. Right. We'll define a moves done as well. Moves, let moves done equals to 0. And we're going to quickly define over here. Let's just remove this. We don't need to check anymore. And over here, let's define another div that will be having a class of moves done. Moves is equals to 0. It should show on the side over here. Take that. And we're going to go to our CSS dot moves done, and we'll give it a color. We're going to give it a color of white and a font size of 20 pixels and a margin of 10 pixels and a font family of Arial. We're going to encapsulate all of this in the HTML inside a container. So we can take our board and our moves done, and we can encapsulate the entire thing inside the container. We'll take the container, and then in the CSS, we can give our container to have the width of 90 view minimum and a height of 100 view height, and display flex and flex direction column and align items center and justify content space evenly. All right, and the last thing which I almost forgot was the button to restart. Restart, class of restart button. Okay, we'll now pull all of these. Let moves done element equals to document dot query selector, and we're going to copy that from here. Moves done dot moves done, and now we're also going to take restart button document dot query selector restart button, and we're going to copy that class. All right, then we're going to have restart button dot add event listener of click, and we're going to pass in the restart function. That should be it. If we try flipping these cards, get a correct pair, and try restarting. Okay, it restarts. We forgot to call SetCards. So if you go to, where is the restart? If you go to restart, we'll just call the SetCards. That should reset the cards for us. And we're going to set the moves done to 0. And in the UnflipCards, whenever we get a correct pair of, if we compare cards, we're going to set the moves done plus equals to 1. In fact, let's just make it so whenever we flip two cards. So if I flip two cards, that's considered as one moves done plus equals to 1. We should also update it. So moves done element dot text content is equals to moves done. That's 1, 2. Okay, we just need to append this. This is equals to moves plus moves done. Moves is 1, 2, 3, 4, 5. And lastly, we can add that to our alert. So we'll change our alert over here with backticks. You have one in moves done moves. And now we can try solving the game. And there we go. It gives us the, you have 124 moves, correct? And we can click on the restart button and it will restart for us all of the game. We can, of course, increase this. All right, what's happening here? Okay. If we restart, we set the board.HTML to 0, set cards equals to 0. All right. There was another thing. We set the target card to undefined and the current card to undefined. So basically, we're going to also reset the clicking system of the player. Anything else to reset? Nothing else. All right. I think so. That's it. Most of it. All right. There's another thing. We need to reset the moves. So we're going to take moves done element dot text content is equals to moves plus moves done. And pretty much that's it. Now we can also try increasing so that you can see that we have made a dynamic board. So if I increase this, this has gotten shorter, but it's working the same. Now that can depend on the size of your screen and we can adjust it accordingly. But for now, let's just stay to a threshold of 6 and you can see it's working correctly. Yep, it is still working correctly. And if we also change to 2 by 2, it will also give us the option for playing with 2 by 2. So that also works correctly. So we have successfully made a memory game. Not only any memory game, we have made a dynamic memory game which allows us to play with any number of cards. I hope you all had enjoyed this video and I'll see you in the next one.